Welcome to another tutorial, mathematics tutorial. In this tutorial I'm going to go over the verification of trigonometric identities. I first want to look at what are called basic identities or fundamental identities that you should know by memory. So let's look over these quickly before I go into the actual verification. The first three that I have here are the reciprocal identities. Sine is 1 over cosecant, cosecant 1 over sine, cosine 1 over secant, secant 1 over cosine, and so on. Tangent 1 over cotangent, cotangent 1 over tangent, and go back to this. Tangent of x, sine x over cosine, cotangent, cosine over sine. And then we have the next identity, sine of minus x is minus sine of x, cosine of minus x is cosine of x, tangent of minus x is equal to minus tangent of x. These identities basically tell you here that the sine function and the tangent function are odd functions. The cosine function is an even function. Even functions have graphs that are symmetric with respect to the y-axis, and odd functions have graphs that are symmetric with respect to the origin. The last three identities are your Pythagorean, often called the Pythagorean identity. Sine squared of x plus cosine squared equals to 1. 1 plus cotangent squared equals to cosecant squared. 1 plus tangent squared equals secant squared. So we're not going to use all of these, but these are basic identities that you need to know by memory. And of course later on as you study trigonometry, other identities will come into existence. So there's quite a few, but these are the basic or the fundamental ones. Okay, so let's look at the first one. Verify each identity. So the first one we have tangent of x times cosecant of x is equal to 1 over cosine. I want to point out to you, make it clear if it hasn't been made clear to you before, that when you're proving identities you have to start off with one side only. You can't assume the equation is true. You're trying to prove that it's true. So you only work with one side, unlike with regular equations where you can multiply both sides by something or add the same number to both sides and then solve for x. With identities you have to show that the left side is the same as the right side, or the right side is the same as the left side. So you start with one side only. Okay, so normally you're going to start with the most complicated side. In general, there are exceptions to that, but in general you want to start with the more complicated side. Okay, so to save me some time here, I'm going to tell you that I'm going to start with the left side. Okay, so here I would write tangent of x, cosecant of x is equal. Okay, so I take my time here so you can read my writing, but listen to me so in case you can't read the writing here. So I want to show that the left side is the same thing as the right side. So notice the right side has 1 over cosine of x. Well, the only way that that's going to happen for me to show that this is the same as 1 over cosine, somewhere on the left side I need to have a cosine. So let's use one of the identities. We had one for tangent of x in that list that I just went over. And it said that the tangent of x is the same as the sine of x over cosine of x. Okay, so you have that. And then on those reciprocal identities, we had one identity that said cosecant of x is 1 over sine. I haven't done this, played with this toy for that long, so I have to take my time here. Okay, so there you have it. In case you can't read this, this is sine of x over cosine of x times 1 over sine of x. So again, I started over here with the left side, so that's over here. And notice, just use a little algebra, these cancel out. They divide out. These become 1s. So what do I have left? Equals 1 times 1 on top, so that's 1. On the bottom I just have cosine of x times 1, so that's cosine of x. And that's proved. Now, could I have started with the right side and shown that it's the same as the left side? Yes. You can kind of see what you'd have to do. Notice, if I started at this side over here, I'd have 1 over cosine of x. And how do I get tangent and cosecant over here? Well, what do I need to get tangent? I need a sine. So I would multiply this by sine of x. But I just can't multiply like that because that's illegal. So I have to divide by sine of x. So all I'm doing is multiplying by sine of x over sine of x. But sine of x over sine of x is 1. You multiply anything by 1, it doesn't change it. So that would give me this over here. So I could start with either side, no big deal. Okay, so let's clear this. Now let's look at the next one. Sine of x over 1 minus cosine of x is equal to 1 plus cosine of x over sine of x. Well, they're pretty much the same in terms of complexity. So it really didn't matter what side you take here. I'm going to take the left side again and show that it's the same as the right side. Okay, so I'll go ahead and write it out this time. I'll say it's sine of x over 1 minus cosine of x. So I want to show that this is the same thing as this. Okay, so here's what I'm going to do. Well, I look at the numerator on the right side and I notice that it has a 1 plus cosine of x. So I have to have a 1 plus cosine of x up there. So all I'm going to do is this. Okay, so let me start it over here. So this will be, so this is just equal, so ignore this little thing here. Sine of x over 1 minus cosine of x. Okay, so I'm just going to multiply the top by 1 plus cosine of x, parentheses. Now I can do that if I also divide by 1 plus cosine of x. So I'm just going to put 1 plus cosine of x down here, and I put that in parentheses. So I'm multiplying this over here. Okay. Now, I'm going to multiply the bottom out. I'm not going to multiply the numerator expressions out because why? Well, because I know I want to be left with 1 plus cosine of x because that's what I have on the right side. So I'm going to leave this the way it is, hoping something will cancel. Okay, so oops. Let me just leave it there. Okay, so here's what I'm going to get then. I just put it over here. Okay, So the top is going to stay the way it is. So this is going to be sine of x, and this will be 1 plus cosine of x. Okay, that's what I have. Now the bottom, it's 1 minus cosine of x times 1 plus cosine of x. Okay, if I multiply that out, just the sum and difference are the same two terms. So this is going to give me 1 minus cosine squared of x. Okay, now recall the Pythagorean identities that I had a while ago. So let me go back to that list. Here at the bottom. Sine squared of x plus cosine squared of x is equal to 1. Okay, so using this identity then, sine squared of x plus cosine squared of x is equal to 1. If I bring this cosine squared over, that's 1 minus cosine squared, which is this over here. That's just going to be sine squared. Okay. So, getting back to this one, I'm just going to replace again so I don't have to do as much writing. I'm just going to mark this out here. If you're actually doing this and the instructor wants you to show the work, you put it in equals here, and you copy this whole thing again, and then you put, in place of this, this would be sine squared x. Okay, so what do I have here? Well, notice I have then sine of x times 1 plus cosine of x, and in the bottom now this becomes sine squared of x. So here I have a sine x and here I have sine squared of x. These will divide out. So this sine of x here divides out, so I'm going to be left with 1 plus cosine of x, which is what I have on the right side. And then this becomes, because I cancel one of these, this becomes sine of x. So this then equals to 1 plus cosine of x over sine of x, which of course gives me this expression there. Okay, and that's what you would do. Let's go to the next one. Okay. Again, I have this plus this is equal to this. So oftentimes when you're proving or verifying an identity and you start with one side and you want to get to the other side, or show that the left side is equal to the right side or the right side is equal to the left side, a lot of it's going to be algebra. Some will be basic applications, making substitutions like I did a while ago, using the basic identities. Some will be adding two expressions, finding the LCD. Sometimes you'll have to factor and then simplify, and things will turn out nice and you'll get the expression on the right side or the left side depending on what you're working on. But now in this case I'm going to start again. The more complicated side is the left side, so I'm going to start off with this. Okay, so I'm going to put this over here, but again, because I have trouble using this little writing toy here, I'm going to save myself some time here and just say, okay, I'm going to take this right here. It's right here equals to what? Okay, so I'm going to have to find common denominator here. So my common denominator is going to be sine theta cosine theta. So if I was going to work this out, combine and get the same denominator, I would multiply the first expression, top and the bottom, by cosine, and the second one I'd multiply top and the bottom by sine. and then I could just combine the tops. Okay, so if I do that, then okay, multiplying this one by cosine of theta, that would give me cosine squared theta minus sine theta cosine theta. Okay. Now, the other way around, I'd have to multiply this one then by sine. So sine times cosine and sine times sine. Okay, so here's what I get. Sine theta times cosine theta, then it's going to be a plus sine theta cosine theta, and then sine theta times sine theta is sine squared. Okay, so this is equal to, well, notice here, minus sine theta cosine theta and a plus sine theta cosine theta, those are the same term. They opposite in sign, those cancel out. Okay, and then cosine squared theta plus sine squared theta, that's one of your basic or fundamental identities. That's 1, so that's going to be 1 over, and in the bottom then I'm going to have sine theta cosine theta. Okay, then I would, just to make it clear, I would write this as, I would say 1 over sine theta cosine theta is the same thing as 1 over sine times 1 over cosine. So I would write that out just to make sure the instructor knew that I knew what I was doing. So it would be 1 over sine, 1 over cosine. But 1 over sine is cosecant. Theta. And 1 over cosine is secant. Theta. Okay. So again, I apologize for the writing here. I'm not used to writing with the mouse this way. But anyway, 1 over sine times 1 over cosine becomes cosecant right here, cosecant of theta, secant of theta, which is, of course, what we're trying to get. Okay. Hope you understood that. I just started using this little writing toy, so I have to practice on it before I can get it down pat. But anyway, this is the verification of identities, and again, I urge you to learn those basic identities, and as you continue in your study of trigonometry, obviously you're going to learn a lot more identities, and you'll get into more complicated identities that you'll have to verify. So this will be it. I'll have some other videos. I have done some videos on trigonometry in my other channel, solving trig equations using the graphing calculator. So let me know if you have any suggestions for copies, for videos rather, and please subscribe so you can have first access on these videos. Thanks again. I'll see you at the next video.